Hello, this is Richard C. I'm a math tutor at Wyzant, and I'm answering this question that came into Wyzant about SohCahToa, and what you need to know here is just what SohCahToa stands for and what it means. It can only be used with right triangles, and so the moment I see a question about a right triangle, I'm asking myself, oh, okay, I bet this is a SohCahToa problem. So in a right triangle, like this, if we want the sine of an angle, we look at opposite over hypotenuse. If we want the cosine of an angle, we want adjacent side over the hypotenuse. And if we want the tangent of an angle, it's opposite over adjacent. Now we're given a triangle that looks like this. It's been actually, the original triangle was rotated a little bit just to confuse you. But I'm just going to set it up in the more traditional way. And we're told that this is 3 and this is 5 and this is root 34. Okay, so they're not asking for all the sine and the cosine and the tangent, and they're not asking, about all the angles. They just want the acute angles. There are two acute angles, so angle J, this angle up here, and angle K here are the two acute angles. L is the right angle, and we're only asked for the tangent. So for the tangent of K, it would be opposite over adjacent, which would be 3. The opposite from K is 3, and then over root 34. Oh, I'm sorry, excuse me. Opposite over adjacent is 3 over 5, excuse me. And that reduces to 0.6, if you like. If you want it in decimal. And on the other hand, I'll just switch color here to green. If we take a look at J now, this is the other acute angle. Tangent of J is going to be 5 over 3, opposite over adjacent. If you're looking at J, the opposite side is 5. So that's O, and then the adjacent side is 3. So if you want to put that in decimal, you could say it's 1.6 repeating. Most teachers are going to be perfectly happy with 3 over 5 or 5 over 3. The question's not asking this, but I'm just going to point out to you that J and K are complementary angles. They add up to 90 degrees. And the tangent of one complementary angle is equal to the cotangent of the other complementary angle. And that might be what inspired this problem. So those who understand cotangent, the cotangent is just the reciprocal. You can see that the reciprocal of 3/5 is 5/3, and likewise the reciprocal of 5/3 is 3/5. And that's where the fact comes from with respect to complementary angles and their tangents and cotangents, but they're not asking that. But it's a very nice, quick, easy problem, and I wish you luck in your further travels through trigonometry. Bye-bye.